Hello, my name is Harald. Welcome to my little workshop. Today I'm going to show you how to build a fine adjustment on the base of a magnetic dial gauge holder. A similar design can be found on Noga measuring stands, for example. Everyone knows the problem that zeroing dial gauges using the fine adjustment on the dial can be quite fiddly. The fine adjust base consists of a hinge made up of two balls. The two plates, which represent the legs of the hinge, are pre-tensioned by two springs. An adjusting screw allows very fine adjustment of the angle. So let's get to work. I found a piece of stainless steel in my scrap bin. Granted, not the ideal material. All the long sides are milled flat. Then I cut the profile in half lengthwise and trim the ends. Now a number of holes have to be drilled. I use the edge finder to find the center and the reference edges of the two parts. I pre-drill the countersinks for the bearing balls which form the hinge joint with the center drill. The final countersinking is done with a 90 degrees solid carbide chamfer mill. I set a stop for the quill and gradually raise the table until the ball fits. All further countersinking is done with the table clamped in Z using the quill stop. In the bottom part I drill a hole with a counter bore for an M8 screw to attach to the magnet. Yes, stainless steel makes some horrible chips. A quick test of the hinge. It works. Deburr the back by placing the workpiece loosely and turning the countersink backwards by hand. This centers the hole and deburring can be carried out after light clamping. To drill the holes for the clamping screws, I clamp the two plates lying on top of each other and align them. I eyeball the position of the holes. Both holes are centered using a spot drill. I pre-drill 5mm for the M6 screws. Both 5mm drills bite out the cutting edges on the material. After pre-drilling with a smaller high-speed steel cobalt drill bit, things work out a little better. I drill the holes at the top to 6.5mm. When countersinking the holes for the spring washers with a 50mm end mill, the clamping proves to be too weak. So I reclamp. It fits. Now cut the M8 thread for the Noga indicator arm. The position is estimated. As will become clear later, I made a serious error of judgment here. Although, strictly speaking, I drilled the hole for the thread slightly too large, at 7 mm, the tab struggles with the material. So I cut it manually, first on the milling machine and then in a vise, because I can work more comfortably there. The hole for the adjusting screw is made. As stainless steel tends to gall, I plan to use a brass bush with a thread for the adjusting screw. As I don't have any round brass in stock, I have to use a piece of square material. This is clamped in the 4-jaw chuck and roughly centered. The first step is to turn the outside diameter for a collar. Then the outside diameter is turned for light press fit. Eight, 9, 7. An M5 thread is drilled. Parting off. And pressed in. A first test with an adjusting screw from the scrap bin shows that I have too little room between the joint of the dial gauge holder and the screw. So I cut a second thread. As the available space is very tight, the thread should be as close as possible to the existing thread, but of course not overlap. To determine the position, I screw a piece of M8 threaded rod into the existing hole and slowly approach the thread with an 8mm drill bit. I use the washer from the measuring arm to check the available distance to the counter bores for the springs. As there is still a little clearance here, I can move the hole 0.5 mm to the left. Then drill another M8 thread. All edges are cut with the carbide chamfer mill. I use spring washers from the spare part box for the tensioning. The sharp edges are normally used for locking screws and are useless here, so they are ground off. Now it's assembly time. The initially incorrectly positioned thread disappears under the disc, so nobody saw it. Please keep it as a secret. A first test shows that the dial gauge can be adjusted very sensitively even when the arm is extended. Yes, I have seen more beautiful workpieces, but the whole thing is very robust and I am satisfied with the function. That's it for today. Thank you for watching and see you next time.